So in this video I am going to show you how to calculate a problem which is regarded to joint probability density. So the question is as follows. So let's say you have two random variables x and y which has this joint density where it is equals to 60 times x squared y when x is within x and y satisfy these strict constraints and it is 0 otherwise. So the first question is you need to verify this f is a valid joint density, and the second question is given y is less than 1/2, you need to find the probability that x is greater than y. Let's do this. So in order to do the first part of the question, you should know that in order to verify this f is a valid joint probability density, what you need to do is you need to integrate this joint density within the support of x and y, and then you need to show that the integration is equals to 1. So the first part of to do that is you need to first find the support or the range of x and y relevant to the question. So to find the support of x and y separately, you should first draw these three inequalities in a scatter plot like this. Then you need to take the common area with respect to all three inequalities. So my first inequality is x is greater than 0. That means this shaded area. Next, my second inequality is y is greater than 0. That means this horizontal shaded area. So now you can see the union or the common area here is this this quadrant. Next, the third inequality is x plus y is greater than 1. So now you can see the common area is this small triangle. So now you can see x is within 0 and 1 and y is within 0 and 1. So now you might think that the support of x is within x and 0 and 1, and the support of y is within 0 and 1, but it is incorrect because you can see that the summation of x plus y is always less than 1. So based on this triangle, you can see that when x is increasing from 0 to 1, y will decrease from 1 minus x to 0. Or you can tell it in the other way. That means when y is increasing from 0 to 1, x will decrease from 1 minus y to 0. So now I am going to verify this based on some equations. So in this question they have given three inequalities which are numbered by 1, 2 and 3. So if you combine these first two inequalities, you can see that the summation of x plus y is always positive. So you can derive this equation 4 by combining equation 1 and 2. Then if you can see that by equation 3 and 4, you can combine these two equations together and write this one. So now you can see that if you combine this equation 3 and 4, this x plus y is within 0 and 1. Alright, so now you have this equation, but you can see that based on this, in order to get the inequality of y, what you need to do is you need to subtract x from the both sides of the inequality. So when you subtract x from the both sides, you will get negative x is less than y is less than 1 minus x, which is equation 5. So now you can compare this equation 5 with your previous equation 1, equation 2. So in equation 2 you probably remember that you had a constraint that y is always positive. So but based on this, you can see y can be negative also, because you have this negative x. So in order to satisfy that equation 2, you can rewrite this inequality by this based on equation 5 and equation 2, because y is always positive. So now you have y is between 0 and 1 minus x, and you already knew that x is all between 0 and 1. So now I am going to show you, based on the inequalities in terms of equations, I am going to show you the range. You can write it as this. That means when x is between 0 and 1, y is between 0 and 1 minus x, based on the equations also. So after finding the support of x and y, now you can integrate the joint density with respect to x and y. So when you integrate this with respect to x and y, and also we have this one variable which depend on the other variable in terms of the inequality, in that case you should write your outer integral with respect to the variable which has numerical terms, and your inner integral with respect to the variable that depends on the other variable. So in our situation, our our outer integral should be with respect to x, because it is because x is from 0 to 1, and this y variable should be since this y is between 0 to 1 minus x, that should be our outer integral, inner integral. Okay, so now I'm going to integrate this. So first I'm going to integrate with respect to y. So when I'm integrating with respect to y, this x is a constant, so I can factor that out like this. So it is 60x squared times integral of y with respect to dy. So after taking the integration, you will see it is equals to 60x squared times y squared divided by 2, and I can put the upper limit and lower limit of y. So when I put the upper limit and lower limit, it will equals to this one, 30 times x squared times 1 minus x squared dx. So now what you can do is you can expand this square term into this function, because it is 1 minus x to the power 2. You can write it as 1 plus x squared minus 2x, and you will get this expression. So now you can factor out 30 from here, and you can multiply each and every term over here by x squared and get this equation. So now you can see all the terms are with respect to x, so you can take the integral. So when you take the integral, you will get this expression, x to the power 3 divided by 3, and now you can substitute the limits, plus x to the power 5 divided by 5, and you have 2 times x to the power 4 divided by 4. And if you substitute the limits, you will get this one, and if you simplify it, you will see that the answer will equals to 1. So in this second question, so we already did the first part, and for this second question you need to find the area when y is equal to or y is less than 1/2, you need to find the area such that x is greater than y. So now they have introduced two additional constraints or inequalities to the question. So let's draw these same inequalities in our chart. So the first additional inequality is this: y is less than 1/2. So now when you consider y is less than 1/2, then our common area is this trapezium like area, which is like this. And when I introduce my other inequality, when x is greater than y, then you can see the common area which belongs to all 5 of these inequality is this triangle. So now you can see in this triangle, you can see that intuitively when y is going from 0 to 1/2, because this point is 0.5 comma 0.5, when y is going from 0 to 1/2, x will goes from what? X will goes from y to 1 minus y, because this line is equals to x equals y, and this line is equals to x plus y equals 1. So when y goes from 0 to 1/2, you can see that x will goes from y to 1 minus y. So I'm going to verify this based on the equation method also. So based on the equation methods, I can write y is like this, because initially I had this inequality where y is greater than 0, and now I have this inequality y is less than 1/2. So basically y should be between 0 and 1/2. And now based on these two inequalities where x is greater than y and x plus y is less than 1. So based on this third inequality, if I subtract 1 from the if I subtract y, I can write x is less than 1 minus y. So now I have what? X is less than 1 minus y, and also I have x is greater than y. So if I combine this inequality 4 and 2, I can write the range of x is, so there should be no inequality here. So my range of x should be y to 1 minus y. So based on these equations, I can write the integral like this. So now my outer integral is with respect to y, and my inner integral is with respect to x, because y is between 0 and 1/2 and x is between y and 1 minus y. So if you try to integrate it as it is, believe me, it will be a very difficult problem, because in that case you will have some cubic terms and some complex expressions. It will take very difficult, or it will take a lot of time to integrate that. So you have to be smart in this case. So you can see this. So if I enlarge this, you can see that this triangle is symmetric within this x equals 1/2 line. So since this triangle is symmetric within this x equals 1/2 line, what I'm going to do is I am going to integrate this area, and then I'm going to multiply it by 2 in order to get the total area. So in that case, first I'm going to integrate y in terms with respect to 0 to 1/2, and x between y to 1/2. Then I'm going to multiply that area by 2. Then it will be a much easier problem. So if you do the integration method, then the above integral will be equal to this 2 times integration of 0 to 1 half and y to 1 half of 60 times x squared y dx over dy, because now you might see based on the above graph, x field goes when y goes from 0 to 1 half, that small triangle, based on a small triangle, x field goes from y to 1 half. So now I can integrate this. So first I can factor out this y, because first I'm going to integrate with respect to x. In that case y is a constant, so I can rewrite it like this, like this. So in that case, when I take the integral, it will be equals to x to the power 3 divided by 3, and I substitute the limits, it will be equals to this, y times 1 half to the power 3 minus y to the power 3 with respect to y. So now you can take the integral with respect to y. So when you take the integral of with respect to y, so first you can simplify this expression as this, then integration of y over 8 minus y to the power 4, and when you take the integral, it will be equals to y squared divided by 16 minus y to the power 5 divided by 5. Now when you substitute the limits, it will be equals to this one. So after calculating the final answer, you will see that for this question 2, the final answer will be 3 over 8, or it is 0.0375. So if you think this video is useful to you, please subscribe my YouTube channel to get more useful videos in future. Thank you.